Microphone, yeah. Eric and Zose.
Yes.
And good afternoon, everyone. My name is George Xiao, founder of Microcvd. Actually, I start my company, start this technology development, not likely solve the problem, just like, oh, maybe have a fun. No. So here you can see the picture on the top. That's 3D printing parts. That's with current state of the art 3D printing technology can print. In the bottom, this picture, this kind of using photolithographic process make those kind of a 3D parts. So my technology try to say, hey, why can't we print those micro scale parts with a different way, not using photolithographic process? So that's my technology come out. And I propose use laser chemical vapor deposition method to direct write the materials on the substrate to make those micro scale parts. And this technology can print metals, materials, ceramics, semiconductor, even polymers. And also CVD can make a nano particles, and also it can print that material in situ during the 3D printing, which integrate with existing state-of-the-art 3D printing technology. So we are making the tool, which is a manufactured tool, which make the micro scale parts. And we can use this technology to make a nano composite, can print the electronics components, and also can print the 3D structures structure with a different function, either with a special mechanical product or electronic function. Here's a picture. So, okay, typically with existing technology, they use a photolithographic process or some kind of wet chemical process to make those kind of structure. So my target is just use my technology to build those parts in 3D scale, just like the existing 3D printing technology to do. But we do in microscope, which you have to look at the microscope or even SEM, scanning electron microscope to look the microstructure. Here's the prototype we have so far in our lab. And here's the equipment looks like. We have a laser part, we have a chamber, vacuum pump, and moving stage, also other chemical delivery system. Here's the parts, we have made in the lab so far. The left one is we try to print the kind of a circuit diamond, demonstrates what we can print with a nickel. It's a nickel line. We can also print a tungsten on the ceramic substrate. This one is the inside of the chamber during the printing. And the right-hand side is the antenna we can print. It's on a ceramic substrate. Oh, here our strategy on IP, because we developed through a manufacturer tool, so we have to design this technology. So it's first we have to secure our IP property, which is to have a special idea to design the equipment. The second one, we have to develop the recipe to make those parts, because during the manufacture, it's involved many parameters like a pressure, flow, laser power, all kinds of stuff. And also, we're also concerned about how to make a different microstructure. Like we can use this technology to make a miniature battery. We can make an antenna. We can also develop a new thermal management system which is it's a micro cooling system for some special application. Here, the potential customer is most coming from, so far we anticipate is from defense sectors, because we got super phase 1 from MDA, DoD, I mean, that's with target, but we also developed the commercial customer. And we have contacted 2 companies so far only, because we thought we may have a build up business relationship with them. One is ARA located in Dayton. They are defense contract to make a RF antenna. The other company is a Fluxtro company. They make a type of resistors, and also they have a magnetic substrate materials. That's the reason we contact them, because we prepare. We already have submitted the Navy proposal, because they asked to develop the antenna on the magnetic substrate. So we have a close relationship, and also we make the sample for Fluxtro company, and they are under review for the parts we made for them. And there's other potential customer like MDA, Navy, Air Force, which is for hypersonic vehicle application, and DOE, which is kinds of involved nuclear physics application. And also MDA is involved electronic printing applications. Here's our business model. We build the equipment, because we are really in the early stage. So we build the equipment. We are going to use this equipment to do the service for the potential customers, especially for the defense sectors. And also we can, it's our business keep going on. When our manufacturer is mature, we may sell it to the customer, and also we can sell the recipe to the customer. And we predict the equipment price at about $500,000. And also we can integrate our technology with existing 3D printing technology to build like a multi-function 3D printing equipment, which can make a nano composite. Here's we take one business is our market analysis is antenna application. It's a typically antenna market size about $10 billion, and their service available market about $3.5 billion. And we anticipate our market share in that application about 6%, which is turn out of $52 million.
8 minutes.
Okay. And here's a key partner. It's just like we don't have a really key partner, but we target the government agency. And here's our financial situation. We have received this Siber phase 1. One is from MDA, the other one from DOE, the total about $300,000. We also get some mini grant from the Ohio government. And this is what we can print. One is on the flat surface as well as on the conformal surface. Here's the team member, is myself and my partner, Dave Telfair. He is a system engineer. We work together to develop this system. And we have 2 advisors. One is Trent Fisher, the other one is Jerry Barry from ARA. He is founder of that company. Thank you.